Class, in this video we continue our discussion of section 4.3 in your textbook on logarithmic functions. We're going to be starting on page 7 of part 2 of your lecture note handout. So on page 7 here we're going to be solving some logarithmic equations for an unknown variable x. So in this first example you're given log base 3 of x is equal to -4. What is x? Well, remember 3 is the base, -4 is the exponent, and so the corresponding exponential equation for this logarithmic equation is 3 raised to the -4th power is equal to x. Well, 3 to the -4th power is the same as 1 over 3 to the +4th power, and 3 to the 4th power is equal to 81. So x is equal to 1/81. So 1/81, right, is the value of x up here that makes the left-hand side equal to -4. Log base 3 of 1/81 is equal to -4. And this next equation, logarithmic equation, you have log base 5 of 125 is equal to x. What is x? Well, the corresponding exponential equation is 5 raised to the x power is equal to 125. Well, 125 can be written as 5 cubed. And now you got the two exponentials. The exponential on the left is equal to exponential on the right. They both have a base of 5. So the exponents must be equal. X is equal to 3. So 3 is what goes in for x up here. Log base 5 of 125 is equal to 3. In the next example, you got to find, we have the natural log of x is equal to 8. What is x? Well, remember, natural log, ln, right, is log base e. So if we write log base e and convert to the exponential equation, we have e to the 8th power is equal to x. Well, x equals e to the 8th power is the exact solution to this equation up here. Using your calculator, the decimal solution, right, of x equals e to the 8th is x is approximately equal to 2,980.958. So this is the exact solution. This is the decimal answer. In the next example, you got to find the natural log of e to the 9th is equal to x. So remember, natural log is log base e. So converting to exponential equation, we have e to the x is equal to e to the 9th. Right? So we got two exponentials. The bases are the same. The exponents must be the same. And so we have x is equal to 9. In the last example, or the next example, you have the natural log of x is equal to -9. Again, ln is log base e. So when you go to exponential form, you have e to the -9th is equal to x. This is the exact solution to this logarithmic equation up here. But using your calculator, the decimal value of e to the -9th is 0.000123 to 6 decimal places. And then lastly, you got to find the natural log of 1 over e is equal to x. Remember, e is equal to 2.718 to 3 decimal places, right? It's a special number in mathematics. Well, again, natural log ln is log base e. And so when you go to exponential form, you have e to the x is equal to 1 over e. But 1 over e is the same as e to the -1 power. Now we got e to the x is equal to e to the -1. The bases are the same, so the exponents must be equal, and we have x is equal to -1. So we put in -1 in for x up here. We have the natural log of 1 over e is equal to -1.